This is a short introduction to the unit circle, and we will use this to create some mnemonics or some tricks to remember trigonometry. You can always come back and revisit these things. We're going to go through them during the lessons, but it's a good point to have them all together. I want to remind you what you have done in the past. Until now, you have learned the Pythagoras Theorem, which is a theorem, something proven, we don't need to prove it every time, that we use to find the length of the sides of a triangle, that it is a very specific, very peculiar, and we call it right angle triangle. And you have done in the past the right angle trigonometry, which is the Pythagoras, and these trig ratios you have done in the past. I want to ensure that everybody remembers them. This is why we use that introduction. So let's start from this part. The Pythagoras theorem tells me that the square of the hypotenuse equals with the square of the small side plus the square of the middle size side. So this is my Pythagoras theorem. Again, I remind you, it's helping me to find the length of the side, the longest or the middle side. So if I'm using this to find the hypotenuse, so to find hypotenuse, to find the smaller sides, A or B side, I am working with subtraction. A squared equals hypotenuse squared. Take away the one I know. Theoretically, I don't know this and I need to know that. And the same manner, B squared equals hypotenuse squared. Take away A squared. This is if I know the length of the sides. Now, there are cases where I know the angle and one side or two sides, and I want to find the other side. So in this case, I'm referring to the trig ratios, and the trig ratios are specifically made to be able to find the opposite or the adjacent side if I know the specific angle. So from the angle theta, this is the opposite side, this is the adjacent side. Adjacent means next to, and of course this is the hypotenuse. So using these terms, now the right angle trigonometry is giving me, this is my hypotenuse, this is my angle theta, this is my opposite and adjacent, gives me the very well-known mnemonics so, ka, toa, which means the sine of angle theta equals to the ratio of these sides, opposite of the hypotenuse. Remind you, that's the so. Ka is the cosine of theta that can be found by dividing the adjacent over the hypotenuse. That's the ka. And in the same manner, toa, that means the tangent of theta angle equals fraction of I find it when I divide the opposite over the adjacent side. Again, tangent is the opposite over the adjacent side. So these are the ratios we use. I want to remind you something else. By now, I hope you have your emulator of the calculator downloaded. Before we start finding sine and cosine, I want you to ensure that you press Shift menu and scroll down and ensure that the angle is on degrees and not radians. We're going to work with this later. Okay, make sure that you set it onto the degrees, and then you can find the sine of any given angle. Let's say the sine of 45 degrees angle equals 0.707. And in the same manner, if you know this number, you can find the ratio. Okay, how you are going to find that? You have to press Shift sine, and then you get sine to the -1 of this 0.707, and if you press X8, it will give you 45 degrees. It is 44.99 because I'm not continuing this part of the fraction. If I was writing here 707.106, that will be the same degree. Are we okay with that? We are going to practice in the class, but this is what I would like you to remember from the past. Now, what are we going to do in this year's trigonometry? We need to introduce to the non-right angle triangle trigonometry, which is something that we will use in our mathematics next year, because most of the triangles are not right angle triangles. So we're going to work with the unit circle, and we're going to work also with radians, and that's how we need to start. We need to start discussing what is the radian and how we measure the angles. I'm going to start with some theoretical background. We know that if this is the center and this is the radius, an angle, imagine that this is 0 degrees, 0 angle, the angle can go up to 90 degrees and then can continue to 180 degrees angle, and then to 70 degrees angle, and complete the whole revolution at 360 degrees, and we can start again. So this is the 90 degrees angle, 180 degrees angle, and so on, 270 degrees angle, and so on. However, I want you to remember that this is not always the correct way to measure it, and sometimes we need to measure as well the angle by using the circumference. We're going to need this, so I remind you that the circumference of this part of the circle, no, let me remind you something else. The circumference of the circle is 2 pi times r, the radius. So we're talking about something that's called the radian angle, which is the angle that's created, and that is between two radiuses. And this is not always like 90 degrees. a radian of 90 degrees, it's a little bit less than 90 degrees. And why is this happening? It's happening because we need to divide this, yes, in 1 pi, and that's the second pi. So this part here, it is pi, yeah, 2 pi's. So when we are going to discuss about the radiant, I want you to remember that 180 degrees equals P radians. Okay, P radians. And sometimes we need to change between the degrees to radians, and other times we need to go from radians to degrees for our calculations. How we do that? When we have something in degrees, we multiply that by pi, and then we divide by 180. Okay, degrees. Pi is a 3.14. So in other words, and I hope you will be able to understand that, we're going to need it later. This circle, or any circle in that regards, is having 6.28 radians. Why? This is 3.14 and this is another 3.14. So actually, this is my 0 pi and this is my p, and this becomes the p halved. Okay, this becomes the p fourth. Yeah, I can have pi third, I can have pi sixth, I can have all these different ways of representing that radial angle. Okay, and this radial angle is actually more accurate representation. So let's come back to this part, how I'm going to transform a degree to radians. I need to multiply the degrees times pi and divide it by 180. For example, 30 degrees will be 30 over 180 pi. That will be pi sixth. Okay, remember that we're going to use it later. How I'm going to do that in mathematics, I have to go to my menu, mathematics. Sorry, I need to press exam and I can't see it. And I need to go 30 degrees divided by 108 times pi. Okay, x times pi, or 3.14, it's the same. So 30 degrees is actually 0.52 radians. Okay, please remember that. Now, what are we doing if we need to go from radians to degrees? I'm doing the opposite. I'm multiplying with the reverse. So I'm taking the radians, I multiply with 180, and then I divide by pi. Okay. This is in your book on page 121, we're going to discuss it later in more detail. You will have some activities to do. You will need to convert degrees to radians. It's easy, and you will see that in your book, for example, when we need to, we don't finish actually the division, we don't divide the whole 3.14, we just try to leave it as pi. For example, if I need to convert 45 degrees to radians, that's how we symbolize radians, see? I'm actually doing what? 45 times pi divided by 180, and I know that this goes here once, this goes here 4, and I'm writing pi over 4 radians. Okay. If this is not something that stays like this, for example, like the other example your book has, I'll leave it here. Your book has another example where you have something like 126.5 degrees and you need to change them to radians. In this case, you multiply by pi over 180. You go radians and you go on and you say approximately this 126.5 times 3.14 divided by 180 gives me 2.21 radians. Okay, this is radian angle. Also, there will be the opposite exercise to convert from radians to degrees. We said we're going to do in this case, we need to multiply by 180 degrees and divide by 3.14. For example, you need to multiply, they can give you something like 5 pi over 6, and you need to make it degrees. That's your radian, you have to make degrees. You really need to multiply this by 180 over pi. You can go and simplify this by this, simplify this by this. So altogether, that's 150 degrees. We need to be fluent in these changes. And you can finish to practice and remember that on page 123, exercise 6. I want you to be able to remember that change where you can transform the degrees to radians and from 0, 45, 90, or 0, 30, 60, 45, 90, 120 degrees. It's a good idea to have that. At the same time, you can watch the video I have uploaded on the website where there is a trick how to remember where is the p divided by 2, p third, p fourth, p sixth, or 11 p's divided by 4. You will find all this needed because you need to remember them. I will try to show you a trick later, but at the moment I will introduce you the first part of this mnemonic trick I used to remember since I was a student. So we have the degrees here and the radian here, and we need to remember that 0 degrees are 0 radians. And then when I have 30 degrees, this is pi over 6. When I have 45 degrees, this is, a quarter, as I saw you before. When I have 60 degrees, this is 1/3 pi over 3. And when I have 90 degrees, this is pi halved. Okay. And 180 degrees is a whole pi. Okay. Remember that, and then the rest will derive slowly. We will fill later this table with the sine, cosine, and the tangent in a very quick mnemonic way. This video will be longer because I need to take it further and show you the terminology. You need to familiarize yourself with this. It's on your book on page 123 again. I want to ensure that we understand what we're talking about every time. So if this is the circle, I'm talking about a sector. This is a sector. Okay, so it's like the pizza piece, it's called sector. Of course, we remember that from here to there, that's called the radius. And of course, this is the center of the circle. We call this circumference of the circle. And we call this part here arc, like this, arc. Usually when I have a line going across, not in this is called, this is a diameter. Okay. Now when I have a chord, that means I'm touching from one side of the circumference, one point of the circumference to another point of the circumference, but this is not the diameter. It's not going through the center. That's the difference. So when it is not going through the center, it's called chord. When it's going through the center, it's called the diameter. When I have this case, I am separating my circle in the minor, it means small, and the major segment. Okay, segment means component. So let me change the color. So that is the major segment, the biggest, that's what means major, and minor, smaller segment. Okay, in the same manner, this part here is the minor arc, and this part here is the major arc. Okay, I think we are okay by this. And what is the arc length? Let me make another circle. This is something you need to remember. So, for example, let's say I have an angle here. This is my theta angle, and this is my radius. This is my center, and this is A and B points on the circumference. The length of the arc is this. Okay. In this case, my angle is measured in radians, and for f in radians, the length of the arc is L, is found by the formula L equals the angle in radians times the radius. So this is radius, not radians. Okay. So the length is this times r. And if we have degrees, I want you to remember that, we need to change this length in degrees. And how we change the length in degrees, we have to take that angle, and that angle has to be a part of a small sector. So if we're going to find the length in degrees, the length equals the theta in degrees divided by 360 degrees times the area, times the formula that gives me the circumference of the circle. So instead of having all the circumference of the circle, that's this part here, we take a fraction of it. What fraction? Equivalent to the length of the angle. So if this is 30 degrees, it will be 30 over 360. Okay, 1/12 of that whole circumference. That's how we're going to find that, and we're going to practice with this later. I'm sorry, I'm still learning how to use this. I don't know why I'm bringing this up. So that's for the moment. I don't want to make the video be huge. We continue later.